All right, welcome to the last class of CSE 103. Next week we'll start up right into CSE 104 and hopefully be able to finish. I don't know. We'll work at it. This section, we're going to start talking about what's on our videotape number 6 of our series called the Hovind Theory. I called it that so nobody else has to take the blame for it in case it's wrong. Okay? I would have to give credit to many people who have been very helpful to me to get ideas on what happened to the world, why did it flood, explaining some of the things that we find in the world about the flood. That's what we're going to talk about, the flood in the days of Noah. Why would the world flood? Walt Brown has a very excellent book that I would recommend anybody read. He disagrees with me on a couple things, but I'll get him straightened out one of these days. Great guy, PhD in physics, Air Force Lieutenant Colonel, lives in Phoenix, Arizona, retired now. Tremendous book. Henry Morris, of course, has been a great influence on me. A guy named Don Patton. There are two Don Pattons. There's one in Texas and one in Oregon, I believe. Don Patton wrote a book years ago called The Biblical Flood and the Ice Epic. And that, as just a young Christian, for me, really answered a lot of questions like, oh, wow, that makes sense. You know, something that would help answer the questions about what caused the flood. All right, let's set the ground rules here. Genesis 1:1 says, in the beginning, God created the heaven and the earth. Well, if he created it, then he owns it. He's the master. He makes the rules, etc. The Bible teaches us that there was not only a canopy of water above. Now, there are some creationists who don't like the canopy theory. Walt Brown doesn't believe in the canopy. He says there was not a canopy above the earth because it would cause problems with heat and things like that. Common excuses they often give. You know, what about the greenhouse effect? It'll trap the heat. It'll runaway heat problem. Well, there are all sorts of ways that can be fixed, okay, and that's God's problem, not mine. But I said, Walt, if you don't believe there was a canopy above the water, above the earth, like the Bible, I think, teaches pretty clearly in several verses. Psalm 148 teaches there might be water still above the stars. Waters that be above the heavens. There could still be. You know, maybe it's earth, air, there used to be a layer of water, layer of stars, another layer of water. The Bible says the Lord sits on many waters. Yes, who knows? Nobody knows what's out past space, you know, or past what we observe as a solar system. So there still could be water out there. But I don't think you're going to explain Genesis 1:6 and 7 and 2 Peter 3. The earth was made out of the water and in the water without having a canopy. And so I said, Walt, how do you explain the giant insects? He said, I have a problem with that one. I said, well, I don't. Not if there's a layer of water. You get more air pressure. You have no problem with giant insects. Anyway, I believe there was a canopy of water above the atmosphere, under the crust of the earth. Now, we'll get into more of that later, because the Bible talks about that twice. It tells us there was water under the crust of the earth. Before the flood, the people lived to be 900 years old, average 912. After the flood, lifespans dropped off quickly, so something changed. Maybe several things changed. But certainly something changed to make them live longer. And I believe very sincerely that dinosaurs were just big lizards that lived with Adam and Eve in the Garden of Eden. We talked about that earlier. They were part of the normal creation. So why would God destroy the world? He's got this beautiful world he made. Why would he wreck the whole thing? And not only why, but how? How did this happen? How can you have a worldwide flood? Why would God destroy his beautiful creation? The Bible says in Genesis chapter 6, God saw the wickedness of man was great in the earth, and that every imagination of the thoughts of his heart was only evil continually. Not like today. Pretty much the same, right? By the way, God still sees. Notice it says, God saw the wickedness of man that was great in the earth, and so he also saw every imagination of the thoughts of his heart. It's interesting that God not only sees your thoughts, he sees the imaginations of the thoughts. See, that's an interesting verse. I'm sure nobody's ever gotten to the bottom of that one as far as studying what it really all means in there. But did you know you can not only think about things, you can think about what you're thinking about to decide if it's a good thought or a bad thought. You can actually pass judgment on your thoughts to decide if they're good or bad. The mind is absolutely amazing. It's not only, 3 pounds of gray matter. There's a physical organ called the brain. And there are more electrical connections in the human brain than there are electrical connections in the entire world. Everything that man has ever built, all of the connections inside every computer, inside every phone system, inside every electrical system in the world, just your little brain has more connections than that. But God understands the imaginations of the thoughts of the heart. I'd like to understand that one of these days. But he said they're only evil continually. And it repented the Lord. Now some people have argued, see, the Bible contradicts itself because it says God cannot repent. And here it says God repented. And we'll get into more of that on videotape number 7, which will be much later on here, when we get into, are there contradictions in the Bible? No, there are no contradictions, not if you've got a King James Bible anyway. You won't find any contradictions in there. If you have some of the other versions, you certainly will find contradictions. I mean, just clear contradictions. And we'll get into all of that later on in this CSE 10, actually in CSE 104, where we should hope to finish up everything. Genesis chapter 6, verse number 7. And the Lord said, I will destroy man. Who's he talking to? Well, I don't understand this either, but the Bible teaches there's a Trinity, Father, Son, Holy Spirit. And apparently he talks to himself and decides what to do. I guess I do that all the time also, you know. Well, I says to myself, self, what should we do about that? You know? So God, the Lord said, I will destroy man whom I have created from the face of the earth, both man and beast and the creeping thing and the fowls of the air, for it repenteth me that I have made them. The earth also was corrupt before God, and the earth was filled with violence. And God looked upon the earth, and behold, it was corrupt, and all flesh had corrupted his way upon the earth. Now, I'm not sure if this all flesh means just all humans, or by this time had something happened, and the animals were also corrupt, and they were violent, and eating each other when they weren't supposed to be, or fighting each other. There have been a few fossils found of dinosaurs or other animals found with teeth marks on their bones, where somebody was chewing on them. I believe one was found with a tooth stuck in the bone. And some have argued, see, that proves they were eating each other before the flood. No, that proves they were biting each other before the flood. It doesn't prove they're eating each other, okay? Maybe they're just fighting for high ground. The flood might have taken 6 months to kill everybody. Let's just, I mean, the flood, Noah was in the ark for a year, okay? Let's just assume it took 6 months for everybody to drown. Flood water just keeps slowly coming up, coming up, coming up. Continents start getting smaller and smaller, and pretty soon people are trapped on small areas, and they're just simply fighting for high ground. People get in some awfully ferocious fights for some awfully dumb things now. Right? So, I don't know that I can answer all the questions about that, but whether it was all flesh had corrupted his way, or does that mean just all humans, or does that mean all flesh? And the Lord said to Noah, the end of all flesh has come before me, for the earth is filled with violence through them. And behold, I will destroy them with the earth. See, that flood not only destroyed man, it destroyed the earth. Now, guys like Hugh Ross are saying the purpose of the flood was just to kill man. It's not what the Bible says. The Bible says God was going to have this flood to destroy them with the earth. God also destroyed the earth. And the Lord said, make thee an ark of gopher wood. Now, when you turn to 2 Peter, it tells us, knowing this first, there shall come in the last days scoffers, walking after their own lust, and saying, where is the promise of his coming? For since the fathers fell asleep, all things continue as they were from the beginning of the creation. For this they willingly are ignorant of. And now there's two things they're ignorant of. Number one, that by the word of God the heavens, and it's plural, heavens, were of old. See, when God made the earth, he just spoke it into existence. The heavens were of old, made by his word, and the earth standing out of the water and in the water. Now, I don't know of another way to explain that other than there was a canopy of water above the atmosphere. Some have argued this phrase is only talking about some of the land was sticking out of the water and some of the land was under the water. I really think that the model that there was water under the crust and then a layer of dirt for them to stand on, which we'll show you in a minute, maybe 10 miles or so of rock or crust of the earth, and then water that God separated into high and low places at the very beginning in Genesis chapter 1, where he said, let the dry land appear, which of course would cause some erosion right there, but all that was probably wiped out at the time of the flood. But and then I think there had to be a canopy of water above. I don't see any way around that. But anyway, verse number 6 says, whereby. Now, whenever you see the word whereby, this means it's referring to whatever was before it. Whereby the world was overflowed. Okay, what's this whereby? Well, you go back to the verse before. It's talking about the water. That water is the same water as what overflowed the world. Well, my Sunday school teacher, when I was just a new Christian, 16 years old, his name was Virgil Hartsock. He was a plumber, massive guy, just a great Christian man. And he taught me so many things about the Bible. As a young Christian, I was just soaking it up, you know. And we'd be reading the Bible, and we'd come across the word therefore. He says, now, whenever you find the word therefore, you better find out what it's there for. It's probably a reason for it. Go back to the verse before. Find out what the therefore is there for. And I'll never forget that. You know, put an impression in my mind that it'll always be there. Same thing with the whereby. It's referring to something before it. So the water that was, the earth was standing out of the water and in the water, whereby, in other words, by that water, the world that then was being overflowed with water perished. The world was overflowed with water. And I don't know how guys like Hugh Ross can teach everybody it was just a local flood in the days of Noah. The Bible says the earth was overflowed with water. And it's the world. Sometimes it uses the word earth. Sometimes it uses the word, like here in verse 5, the heavens and the earth. And here it uses the word world. So the earth was overflowed, the world was overflowed, doesn't matter. The whole thing was completely covered with water. So we're going to try to answer some questions here tonight and for the next several weeks. Why did God use a flood? Why not just say, okay, everybody die? Wouldn't that save Noah a lot of work? I mean, why have a flood? Why make Noah build this huge boat and fill it full of animals and stay in there for a year? When I asked Hugh Ross the question, you know, why would God tell Noah to build the boat? If it's just a local flood, tell Noah to move. I mean, surely God could figure that out. And Hugh said, well, all of God's prophets in the Bible needed a platform to preach from. And so the ark was his platform. A 450-foot-long platform full of animals and food? Right. Explain this to me, please. I don't get it. Anyway, he's so desperate. See, I don't want to pick on Hugh Ross too much, but what he teaches is just plain heresy. And he's a nice heretic, but he's a heretic, okay? And it's just flat wrong, and it's seriously wrong, because it goes against so many other doctrines of the Bible. Like, why did Jesus die on the cross? If there's already death in the world before Adam came, then death was part of God's plan. Boy, I get real nervous about that. You know, that looks to me, that puts our red flags in my mind anyway. So, I think some things we ought to consider concerning the flood. Number one, a flood left evidence. A miracle would not. I mean, if everybody had just died, and Noah's sons had survived, and Noah and his family, and then they would tell their kids, hey, the reason we're here the only ones in the world is because God made everybody die. After a couple of generations, people are going to start to doubt that, aren't they? Yeah, right. Everybody died? Sure. Gee, you just happened to be the only one, huh, Noah? Yeah, right. Sure. You killed them all, didn't you? Right? I mean, something like that would come up. See, the flood left evidence. We still find the evidence today. You go digging around just about anywhere in the world, you'll find fossils. You still see evidence everywhere you look. When they climbed Mount Everest, they got up to 26,000 feet above sea level and began finding petrified seashells. There's evidence of this flood everywhere. It's just yelling at us from the rock record. Okay. Secondly, the effects are here for all to see and to remind us of God's judgment on sin. Just like with kids, you have to constantly remind them certain things you don't do. Like my dad always had the paddle on top of the refrigerator with the handle sticking out just a little bit. When you go to get the milk, you see the paddle up there. Oops, that's right. Just a little reminder. We need reminded that God hates sin, or else we'll do it. And so everywhere you look, you see evidence. And I think we need to train our young people to look at the world as a reminder. When you see fossils, when you see Grand Canyon, these things ought to be reminders. Wow, God hates sin. But it's not anymore to the average student, is it? To the average student, these are reminders of the evolution theory, aren't they? That's how far we've got our brain off track from where it's supposed to be. Ought to be constant reminders that God hates sin. Thirdly, a warning time while Noah's building the ark gave them time to repent. It tells us in 2 Peter, while the ark was preparing. Can you imagine we don't know how long it took Noah to build the ark, okay? There are a couple of verses that people get confused. Turn in your Bibles to Genesis chapter 6. Genesis chapter 6, and I'll show you here a couple of only verses we have that really deal with this. And it came to pass, verse number 1, when men began to multiply on the face of the earth, and daughters were born unto them, that the sons of God saw the daughters of men, that they were fair, and they took them wives of all which they chose. And the Lord said, My spirit shall not always strive with man, for that he also is flesh. Yet his days shall be 120 years. Well, now, wait a minute. People have made all kinds of crazy doctrines over this verse. Let's read what it says. Okay? The Lord said, My spirit shall not always strive with man. I'm not always going to argue with you. For that he also is flesh, yet his days shall be 120 years. That's all it says. Now, what does that mean? Some people have said, see, God said in the Bible nobody would live past 120. And there have been people proven that they live past 120. And therefore, there are contradictions in the Bible. Slow down just a minute now. Did God say nobody would live past 120? No. But they start off with a false idea because God's verse. This verse does not say nobody's going to live past 120. Here's what it says. For that he also is flesh, yet his days shall be 120 years. Is this God warning them? A flood is coming in 120 years? I think so. I think that's the only way you're going to interpret this. God says, in 120 years, I'm going to destroy the world. But I wouldn't be dogmatic on that, but I think that's the best way to interpret that. And some people say it took Noah 100 years to build the ark. I think so, but I can't prove that either. The Bible doesn't say how long it took Noah to build the ark. He might not have started right away. It might have taken him 50 years to build it. He might have hired all the neighbors to help. He might have built it in 1 year. The Bible simply doesn't say. But while the ark was preparing, people could see what's going on and say, wow, I better get saved. Now, if you look at the chart that we have, the chart in the back of the seminar notebook, which tells how long they lived before the flood, the Bible has a verse that just really is, to me, a heartbreaker just a little bit. Back in Genesis chapter 5 and verse number 30. Genesis 5:30, and Lamech, that's Noah's daddy, lived after he begat Noah 495 years, and begat sons and daughters. Noah's daddy, Lamech, for 495 years, 595. Oh, okay, new glasses, can't get used to the stupid thing. All right. For 595 years, Lamech had more children. These are Noah's brothers. How many of them went on the ark? None. Noah had brothers and sisters that apparently drowned in the flood. Certainly, nephews and nieces didn't even listen to their own uncle. It's also interesting, if you look at the dates, Methuselah died the same year the flood started. Now, you can't be dogmatic and say it was the same day. The Bible doesn't give us enough data, okay? But he certainly died the same year the flood started. Anyway, this building of the ark, however long it took, gave them time to repent. Okay. What caused the flood in the days of Noah? What about Pangea? How many of you have been taught that all the continents used to fit together in a big supercontinent called Pangea? You ever heard of that before? Okay. What about Pangea? What about the Ice Age? Where does that fit in? And what froze the mammoths? I've got a mammoth, Eric, in the suitcase or in the box. Would you see if you can find that someplace around here? Maybe it was in the... Yeah, we had it for the kids out today. What would it take to freeze an elephant, a big, huge, hairy, hippie elephant, to freeze it standing up? Yeah, bring that up too. That's a mammoth tooth. And the mammoth vertebrae. We'll just talk about the mammoths here for a minute. How did the mountains and oceans form? Why would the world suddenly flood? Could it really rain enough to completely cover the world? I mean, is it possible to rain that much? Where did all the water go? And where is the evidence? My first debate that I ever did, University of West Florida, one of the students stood up in the audience. We had a question-answer time at the end. And this kid said, Mr. Hovind, is it possible to rain enough to cover the world? I said, today? No, no possible way. If all the moisture in the entire atmosphere condensed, it would probably rain about 2 inches all over the world.
Even that would cause some problems.
That'd cause some problems in some areas, but you figure the ocean would raise 2 inches. You wouldn't notice that, okay? If the land had 2 inches of water, you probably wouldn't notice it much at all. I mean, if you lived right on the beach may come up 6 inches or something, I don't know, but it's not going to be a big deal. He said, but you really believe the earth was totally covered by water? I said, oh, yeah. Well, we'll get into that in a minute, but where did the water go? I get this question a lot. Have you had that yet when you do debates or something, or question, where did all the water from the flood go? Well, first place, 1 drop of water will completely cover the earth if you spread it real thin. Right? If you shrank the earth down to the size of this globe right here, all of the water in all of the oceans and all of the rivers and all of the lakes would barely fill a tablespoon at this scale. Not much. So where is the evidence? Okay, let's talk about Pangea. Students are taught all of the continents used to fit together. One big, massive supercontinent called Pangea. This textbook says, yes, boys and girls, Africa and South America seem to be a perfect fit. You've seen this in your school, right? Pangea. Here's the evidence they will give you to support their theory. They will say the shapes of the continents seem to fit. Similar fossils are found on opposite sides of the oceans, and there are magnetic reversals in lines in the mid-Atlantic ridge. They will point out, like this map does, showing the 2 red dots across in Africa and South America. They say, see, we find these same kind of fossils in opposite sides of the ocean. Yeah? What does that prove? Does that prove the continents drifted apart, or could it prove there was a worldwide flood and those animals drowned and traveled just about anywhere all over the world? I would say it's reasonable to say it's a fact. Similar fossils are found in South America and Africa. I don't argue with that. What does it prove? Is what I'd like to know. It certainly doesn't prove the continents broke apart, does it? 3-inch galvanized sheetrock screws are used in this building, and they're also used in Eric's house down the street. That proves they broke apart. No, it doesn't, okay? Doesn't prove any such thing. Here's what they don't tell you about Pangea. Africa was shrunk 35 to 40% for the drawings. Now, when you measure an object, and you're going to determine how much it has been diminished, or shrinking, there are several ways to do it. Let's suppose we go from a 8.5 by 11 sheet of paper down to a 8.5 by 5.5. Cut it in half, okay? Was it shrunk 50%? Well, if you go from 11 to 8.5, the length from 11 to 8.5 is not a 50% reduction, is it? The area has been shrunk 50%. The length has not. If you went from 8.5 inches wide to 5.5 inches wide, that's not a 50% reduction. And you have to be careful when you talk about percentages, because it's so easy for people to deceive other people. Congress and news media does this all the time, you know. There was a 30% rise in, crime. Well, compared to what? You got to really watch these, because numbers and graphs is so easy to be deceptive. And we can get into more of that some other time. But Africa was shrunk 35 to 40% in area to make your drawing. Mexico and Central America are completely gone. Here's a map of Pangaea from McGraw-Hill Earth Science, 1973. Where is Mexico? You can get any textbook that shows Pangaea and just state, where's Mexico? Where's all of Central America? I mean, I've been to most of those, or many of those countries, flown over all of them. Some pretty good size. So they just simply take them out because it makes the continents not fit. So anything that, makes a theory not work, well, let's eliminate it. It's just not, that's not the way science works. They also don't tell you, Europe and South America were rotated counterclockwise. Africa was rotated clockwise. Notice the way they would have to twist to make them fit. South America twisted one way, Africa twisted the other way. They also don't tell you the obvious. To me, I don't know how anybody can overlook this one. If you take the water out of the oceans, there is dirt underneath. Isn't there? I mean, when you look at a world, you say, wow, this is water, this is land. Well, that doesn't mean there's nothing under the water, right? I bet you could point out that the opposite sides of most rivers in the world are parallel, right? Does that prove the sides broke apart? No, it's a low place full of water. That's all it is. So the continents are not floating around like lily pads in a bathtub, okay? They are connected. They're, people say, do you think the continents were once connected? I say, what do you mean? They're still connected. It's underwater, but so, they're still connected. What do you mean, were they connected? Yeah, they still are. There are cracks all over the earth, okay, like this mid-Atlantic ridge, which was just recently discovered, in the last, 30 years, I think. Some textbooks, like this textbook, says there are magnetic reversals in the mid-Atlantic ridge. Okay, let's cover this real quick and then take a little break here. Notice what the book says here, figure 13-8. Changes in magnetic polarity of the rock on both sides of mid-oceanic ridges reflect the past reversals of Earth's magnetic poles. This is evidence for seafloor spreading. And like I tried to teach Eric for years, and he's catching on pretty good, almost always there is a built-in assumption. They tell a lie and then build a whole theory on that lie. Dinosaurs lived millions of years ago and they're extinct. So, how did they go extinct? And they go off into their big long stories. Well, you started off with the wrong, the wrong lie. Okay, they didn't live millions of years ago and they didn't go extinct. Here they start off by saying, the Earth has magnetic reversals. That's the problem. Then they say, this is evidence for seafloor spreading. One of the evidences they will give you to prove the seafloor is spreading apart is magnetic reversals, and there aren't any magnetic reversals.
What would a magnetic reversal prove anyway? I mean,
well,
even if there were, would that prove that it's spreading?
It still wouldn't prove anything. That's a good point. See, many types of rock will store a magnetic signature, it's called. There are certain kinds of rock. I remember up in Illinois, we got a load of gravel for something my dad was building, or maybe it was out at the lake at my brother's house or something. Anyway, we noticed when you dropped nails, and you picked up nails while you're working on the house, these little rocks would stick to the nail. They're magnetic. I mean, they came out of the truck that way. The guy dumped them in the yard. It's magnetite. Just a naturally occurring rock. Certain types of rock, if it has any iron in it at all, it has a possibility of being slightly magnetized. Certain types of rock, like the lodestone, magnetite is lodestone, I believe, the same thing. You can set it on a little block of wood and set it in a pan of water, and it'll turn, point north to you, tell you which way is north. See, the Earth has this big, huge magnetic field around it, and these magnets will orient themselves because north seeks the south and south seeks the north. Opposites attract, except in San Francisco. But the poles of the magnet will turn, and line up with the Earth's magnetic field. And we'll get into more of the Earth's magnetic field later because there's some very interesting anomalies in the Earth's magnetic field. But nobody knows for sure what's causing the Earth. Why do we have a magnetic field? I don't know anybody who's been able to give a convincing answer of why we have one. The fact is, we do have one. Okay? That is one of the things that causes the northern lights. I've only gotten to see them twice. 3 times, I think. How many times have you seen them? That one time in?
Twice. First time in South Dakota, both times in South Dakota.
Both times in South Dakota. Occasionally, the northern lights are visible clear down, here. It's real rare. But generally, around the polar regions, the sky just lights up, and it's the most incredible thing. How many of you ever seen the northern lights? Becky, where did you see them at? In Pennsylvania? Man. The magnetic field of the Earth deflects radiation in around the poles, and you get the northern lights, aurora borealis, and the southern lights, aurora australo, some Latin guy. He's probably dead by now, but he named it that. Australis, aurora australis. I used to know all that stuff. It doesn't matter. Anyway, named after Australia, the southern part. So there's a ring around the North Pole, and from satellites, or from space, they can see it. You can see the sky lighting up like a ring. Same kind of effect you get in a fluorescent bulb. If you look at a fluorescent light bulb, there's a little bitty wire at each end, and electricity is making all of the gas in there light up. It fluoresces. The charge from the sun's particles is causing the atmosphere to fluoresce. And it's the most incredible sight. And if you've never seen it, you really need to go somewhere and see the northern lights. It's like, wow. Remember we laid there in the back of the truck and watched it, for an hour? And we kept we were talking to Mom on the phone saying, oh, you got to see this. You can't see it through the phone. It's a little hard to videotape, I think. Maybe not, but there's not a lot of light out there. But it's just all different colors and stuff like that. Who cares? Well, anyway, the Earth's magnetic field causes the northern lights, causes the southern lights, causes the compass to point north on your car. And here they are telling the kids this magnetic field has reversed. Now, in an electric motor, electricity running through a wire creates a magnetic field. Or a magnetic field creates electricity running through the wire. Either one. If you wrap a wire, a big coil of wire, hook a gauge to both ends of the wire, just wrap it around and around and around, wrap it around a magnet, and then pull the magnet out real fast. And your gauge will go, doot. It creates electricity. A magnet moving through a coil creates electricity. Well,
could you have a round magnet just spinning?
That's what power plants are.
No way.
Huge magnets spinning inside a coil of wire. Now you got to have something to keep that magnet turning. And so you have either steam or waterfall or something, okay? Any way to turn the magnet. You turn the magnet inside the coil of wire and it produces electricity. So electricity, you plug in your drill and the electricity goes through a coil of wire and that makes the magnet spin, or the magnet spinning will make the electricity. Either one, okay? They're going to say the Earth's magnetic field has reversed, though. Well, now, nobody knows for sure what's causing the magnetic field, and we certainly don't have a clue how it could possibly reverse the magnetic field. This textbook says at the bottom, the pattern of magnetic stripes as found on the seafloor along the mid-ocean ridge southwest of Iceland. Ages of rock are given in millions of years. Well, at the top it says, reversals of Earth's magnetic field leave a record in the form of magnetic stripes in the rock flowing out along the mid-oceanic ridges. Here's the theory. Here's how it's supposed to work. When a rock is hot, melted, really hot, like lava coming out of a volcano, if there's any iron in there, or anything that's capable of being magnetized, it's just flowing around like water, but the magnetic field of the Earth is going to try to pull it in line. And as the rock cools off, it ends up stuck there. And so this is called the magnetic signature. Like they signed it. Okay, this is where it was when the Earth's magnetic field got done, when it cooled off. Well, then they're going to say that these stripes are reversed. And absolutely is not true. Those stripes are not reversed. There are no magnetic reversals in the ocean floor. This fellow said in Science magazine, volume 204, it is clear that the simple model of uniformly magnetized crustal blocks of alternating polarity does not represent reality. A very complex way of saying, folks, it ain't true. Okay? What happened was the Earth's magnetic field had strong places and weak places. In some areas, as what they did is they drilled down in the floor of the ocean. Real expensive project. You got to park the boat out there and try to keep it still while you drill a hole 2 miles down underwater. And they brought up core samples and they checked the magnetic signature in these core samples. That part is done very scientifically, okay? And they check the rock and find out it has a certain strength of magnet, because magnets are measured by their strength. Some magnets are stronger than others. And they made maps of all this on the ocean floor of where the magnetic field was strong and where the magnetic field was weak. And after they got all done mapping it, they ended up with this map right here. Let me show you what they really got. I think I've got that. I guess it's not. I'll have to add that back in. They got kind of a tangled up mess, but it did appear to have some kind of pattern to it. But it was stronger and weaker. Some areas were stronger, some areas were weaker, and there seemed to be kind of stripes of strong areas and strong stripes of weak areas, of weak magnetic signature. Well, some guy drew a line through the middle, which is the average, and said everything below average is a reversal. And that's where the mistake was. Just because it's below average doesn't mean it's reversed. If we lined up everybody in Pensacola and found out the average height was 5'6", does that mean everybody 5'5" is reversed? Or are they just less than average? They're not down in the ground, okay? They're just less than average. And the low places on this sine wave are not reversed. They're just lower than average. So, make that a quiz question. Are there any magnetic reversals on the ocean floor? No, there aren't. There are no magnetic reversals, only areas of stronger and weaker magnetism. We'll take a little break. When we come back, we'll explain why, though, they keep teaching the Earth's magnetic field is reversing and the seafloor is spreading. Now, the seafloor may be spreading. I'm not questioning that. But it's very important that why they teach that. We'll cover that right after the break. Let's continue here now, talking about the Earth's magnetic field. The Earth's magnetic field is getting weaker. In the early 1800s, a guy named Gauss, G-A-U-S, I don't know how to spell his name, G-A-U-S-S-E or Gauss, I forget, just one S. Anyway, Gauss figured out a way to measure how strong is the Earth's magnetic field. There's many different ways to measure the strengths of magnets. For instance, if you took a magnet and see how many paper clips it'll hold up. You know, to make a string of paper clips. Eventually, it won't hold the string anymore. It's not strong enough. A stronger magnet will hold a longer string. You can get an electromagnet, like at a junkyard. The guy flips a switch, and electricity goes through this coil and becomes a real strong magnet and picks up a car. Shuts the switch off, electricity stops flowing, car falls. The electromagnet only works as long as the electricity is running through the magnet. You can do that. You have them on your car if you have an electric door lock. When you hit the switch, it is sending electricity around a coil of wire, creating a magnet just for a second that pulls a metal rod down. When I was in electricity class in high school, I made for a project a golf ball return. You hit the golf ball, it flows into the hole, and it hits a little switch in the hole, which triggers an electric circuit and makes a magnet. I just had a steel rod, would go, there's a coil of wire and a steel rod. As soon as electricity went through there, boink, it would come out and hit the golf ball and knock it back out to you. You don't have to go get it. What a waste of time. First place, knocking the ball in the hole is a waste of time. But, right? Okay. But the golf ball returns that way, just a little magnet, you know, just becomes a magnet momentarily. You can actually shoot a steel rod that way. It's a very inefficient way to do it, but it can be done where you have a rod and a coil of wire, you energize it, shoots the thing through. The problem is, when it gets to the middle, as soon as it gets past the middle, it starts pulling it back. So the trick is, as it's coming in, shut your power off so that it'll keep going. Otherwise, it'll go and stop in the middle, which won't do any good. Okay, as far as shooting it, there's all sorts of other ways, more inexpensive ways to propel objects through space. But the Earth's magnetic field, ever since it has been measured by this guy named Gauss, it has been losing strength. it has now lost 6% of its strength in the last 150 years.
Could the gravitational pull hold the atmosphere in?
Gravity holds the atmosphere in. It has nothing to do with the magnetic field.
Is gravity... okay.
I don't think gravity and magnetic field are related at all.
Is gravity declining at all?
No, gravity's all staying the same as far as we know. Gravity appears to be directly related to the mass of the planet. How many pounds of dirt are here? That doesn't change. It's maybe increasing a little as more cosmic dust and stuff falls in, but it's insignificant. So magnetic field and gravitational field are totally unrelated to each other. Some planets have a magnetic field, and some planets and some stars or some moons have a magnetic field, some don't. I don't remember if the Earth has, if the moon has a magnetic field or not. We could look it up. If it does, it's not much of one. Okay. One of the Jupiter's moon, Ganymede, they discovered as they sailed out there past Jupiter, one of its moons has a real strong magnetic field. Most of them don't. They would all have gravity that would be directly proportional to their size. A bigger planet would have, or denser planet, more massive planet is the proper word, would have more gravity, but that would be unrelated to the magnetic field. Okay, the Earth's magnetic field has been declining. As they've studied this data, they said, okay, that means it used to be stronger. Right? How strong can the magnetic field get before you start to create a problem? Thomas G. Barnes was a PhD in physics and taught physics at the University of Texas, El Paso. I've spoken there several times at the university and in El Paso at different churches. Thomas G. Barnes is, I think, probably like 82 years old now. He's pretty old. Brilliant man when it comes to the Earth's magnetic field. He was considered one of the world's experts on the Earth's magnetic field. He said, the magnetic field of the Earth is declining. Here's the data. He said, this shows it cannot be more than 25,000 years old. We'll get into more of that in a minute, but according to Thomas Barnes, the magnetic field of the Earth puts an age limit on the Earth of 25,000 years. Now, those who believe in evolution don't want any age limits. They certainly don't want less than 25,000 years, right? You got to have zillions of years to make your theory look good. I think it looks bad anyway, but even with zillions of years. But you certainly look really bad without zillions of years. So, factoid. The Earth's magnetic field is getting weaker. I've never had anybody argue with that one. Even the atheists will agree, yes, it's getting weaker. But, they say, that's only because it's getting ready to reverse again. What do you mean again? It never has reversed. So they teach the Earth's magnetic field is reversing because that's the only way they can get out of the problem. The fact is, it's declining. All we've ever measured is it's declining. Nobody's ever seen it reverse. We don't know how it could reverse. If you want to believe it did, that's fine, but that's not science. Psalm 24, verse 1. The earth is the Lord's, and the fullness thereof, the world, and they that dwell therein. Then it says in verse 2, He hath founded it upon the seas. What does that mean? Founded means where you put the foundation. He put the foundation of the earth, He founded the earth upon the seas. Strange verse, isn't it? Look at Psalm 136. To Him that stretched out the earth above the waters. Now there's another strange verse. Did He stretch the earth out above the waters? Now some people, especially back during the Dark Ages, say 500 years ago or 1,000 years ago, were teaching, most Christians didn't believe this, but some people were teaching the earth is flat and it's on top of a layer of water because of this verse. Is that what that verse says? No. It doesn't say the earth is flat and it's stretched out on top of a layer of water. I think it does say He stretched out the earth above the waters. So there was water under the earth. That doesn't mean under the earth like this, under the earth. Under the part we're standing on. Okay? A layer of water under the crust of the earth. That's the water, I believe, that came shooting out at the time of the flood. Look at Genesis chapter 7 and verse 11. In the 600th year of Noah's life, in the 2nd month, in the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. It's very important you notice the sequence here. Hey, can Andrew bring me a glass of water, too, when you get time? No. Notice the sequence here. First, the fountains of the great deep were broken up. Then, the windows of heaven were opened. Some people say, how can it rain for 40 days and flood the world? Here's typically what an atheist will do. Okay, a guy called me today, talked about this. He said, Mount Everest is 29,000 feet high. I said, yep, you're right. He said, in order for it to rain that much, it would have to be, you know, X number of inches of rain per day for 40 days. And it can't rain that much. The atmosphere won't hold that much. Plus, as atmospheric moisture turns to water, it releases heat. See, when you turn water into moisture, you add heat. You take water, turn it to steam, you boil it. You have to add energy. When the steam condenses back to water, it releases the energy. That is called the latent heat of condensation. As water condenses, it releases heat. And he said that much moisture to produce that much rain to cover Mount Everest would produce so much heat it would completely destroy the earth from the heat. I said, you're absolutely right. See, they do all the right calculations about how many joules of energy and how many, how much heat and all this stuff, but it's all based on a faulty assumption. Did the water have to cover Mount Everest? No. Mount Everest was under the water. How high were the mountains how high were they before the flood? Was Mount Everest even there before the flood? We don't know any of that, okay? One drop of water will cover the earth a mile deep. Or one drop of water will cover the earth if you spread it thin. And there's enough water right now in the oceans to cover the earth about 1.5 miles deep. The earth is 70% underwater. I mean, there's an awful lot of water out there. I flew back over to Pacific. You remember coming back from Australia. That's a long flight. I mean, it was hour after hour after hour. And the pilot came on. He said, folks, we've got a 200-mile-an-hour tailwind. We're going 750 miles an hour. I just thought you'd like to know. That's the fastest I've ever gone. 700, that's past the speed of sound. Of course, we were in the wind, so we were not breaking the sound barrier. But even at that incredible speed, it was many, many hours just to get across the Pacific. So I told Brian, my computer guy in my office, I said, Brian, the Pacific Ocean is huge. And in his typical wit, he always thinks several levels beyond everybody else, He says, yeah, and that's just the top of it. Wow. What a thought. It was brilliant. That was just the top of it. There's just an awful lot of water out there. So, when you figure that all the fresh water in the world, all the lakes, all the rivers, there's a lot of water there. It's about, what, not even 1/2% of the water in the world? Somebody, I forget the number now, it's like 99.5% salt water in the world.
Is there really a decline in the amount of water?
There's a decline in the amount of usable water.
Yeah, usable.
There can't be a decline in the water.
Unusable water.
Right.
Is that something we really need to worry about right now?
Well, in some areas it becomes a serious problem. Some areas are using water faster than they can get it. Southern California doesn't get much rain. I mean, there's been talk, like for Africa, some of the Arab states where it's just extremely dry, especially along this coast of Africa, there's been talk of getting icebergs from Greenland, dragging them down with boats and letting them melt. Because fresh water floats on salt water. Salt water is denser. Let the iceberg melt and pump the water off the top. That's how desperate they are. Other areas, like last night around here, there's plenty of water. Washed away the sod we put out here. You guys get rain over at your place? Man, I mean, I don't know how much we got, but it was a lot. Anyway, it's important to note, though, that the flood was not caused by the rain. Look what it says. The fountains of the great deep were broken up, and the windows of heaven were opened, and the rain was upon the earth 40 days and 40 nights. Later we'll see the water kept coming up for 150 days. Well, if the water comes up for 150 days, it's not all coming from rain, right? It came from inside the earth. The water that used to be under the crust of the earth came to the surface. Now, if you take a nice big juicy grape, set it out in the sun, let it dry out, the moisture inside the grape leaves. The skin of the grape stays the same size, only it wrinkles up, right? If there was water under the crust of the earth and it came to the top, the crust would fall down a little bit, causing a slight wrinkling effect. Same surface area now has to be wrinkled up in some of the waters on top in big puddles that we call oceans. It just came to the surface, that's all. Walt Brown's book, In the Beginning, has a really excellent section about what he calls his hydroplate theory. He thinks when God made the earth, there was certainly water under the crust of the earth. When it came shooting to the surface, it came out along cracks. The earth cracked up like an eggshell. I saw a slow-motion picture that somebody did once of a balloon getting popped by a needle. They got to take these cameras and run them, a zillion frames per second and then play it back real slow, okay? And it showed the hole in the balloon, and the crack actually went around the balloon. Of course, our eye can't see it, but with the slow-motion camera, it was really cool. You could watch the crack race around the balloon. Same thing happens during an earthquake. The crack will actually move across the earth, sometimes at 2,000 miles an hour. This picture here shows Walt Brown's concept of what he thinks the earth was like when the fountains of the great deep were broken open. He says the cracks, as the water is shooting out, would get wider and wider just from simple erosion. Water shooting up, plus it's like when you uncork a bottle of pop that's been, if you shake it up first and then uncork it, once it starts to go, it starts going faster and faster. I've never tasted any champagne, but they say that does the same thing. You see the guys, when they win the race, they pop the cork and the champagne goes shooting out, okay? The pressure of the weight of the rock on this water would cause it to squirt up through the top. As it goes up, it's going to go real high. He thinks, 10 or 20 miles into the atmosphere. Along the way, it's going to tear pieces off the side of the crack, and the crack's going to get wider. Here's his concept, some pictures from Walt Brown's book here in the beginning. The water shooting up from under the crust of the earth. As the crack raced around the earth, the 10-mile thick roof of overlying rock opened up like a rip in a tightly stretched cloth. Water exploded with great violence out of the 10-mile deep slit, which wrapped around the earth like a seam of a baseball. As the crack gets wider and wider, eventually it reaches a point where the layer of rock underneath, which is called the basalt, would bulge up. He uses an interesting illustration. If you take a mattress and squeeze it from the ends, if you push from the ends, pretty soon the mattress will bulge up in the center, or a spring like this picture here shows, okay? If it's compressed from the ends, but there's weight on top, it can't bulge up. That's why most springs that are under compression, you put them in a tube so they can't bulge out someplace. But if the earth had a layer of basalt and a layer of rock on top and with water in between, as the rock on top gets farther apart, the basalt is going to bulge up. Basalt is relatively soft, half-melted rock. As the basalt lifts up then into that opening crack, it's going to cause the continents to slide away. They're going to keep sliding based on several factors. How steep is the ground? How much water is still left to lubricate it, because that water is leaving all the time. Eventually, enough water has left that it comes screeching to a halt. In some areas, if it bulged up real slow, it would slide off real slow. Now, it's not just sliding off into nothing. I mean, the Earth had a solid crust. As it slides off, somewhere else it's wrinkling up. It's like during a car accident. You know, when your front bumper moves in toward the windshield, the metal has to wrinkle up to absorb all of that. And a good engineer will take advantage of that. Okay, the metal's going to wrinkle up. Let's use that to absorb some of the energy of the impact so it doesn't kill the people inside. And that they try to use all that stuff. But he says the Earth's crust slid off, causing the basalt to lift up in the center even more, until eventually all factors are equalized, the stresses are neutralized, and everything stops. Some of the water is probably still trapped down there. Huge areas of subterranean water in the crust of the Earth. It still is today, okay, called aquifers. As the basalt cracked, the water would rush in to the cracks. Now, if you take a magnet and stick it in an oven and heat it up, if it's not oriented north-south, it'll gradually lose its magnetic strength. A hot magnet will not store it won't be very strong. A cold magnet will be stronger. It'll store the magnetic field better. So here's water rushing into the cracks of hot basalt. That's going to cool it off, right? That's going to store a strong magnetic signature in the rock. Areas where the basalt is still hot, it's going to have a weaker magnetic signature. So when they're measuring the magnetic signature on the bottom of the ocean floor, they were not measuring magnetic reversals. They were really measuring where the cracks are, which are now full of sediment. You know, they filled in with stuff. They've been there for 4,400 years. So you can't actually see most of the cracks down there. But you can detect them with the magnetic signature. That's all it is. It's not a magnetic reversal. Here's that picture we were looking for earlier of what they, on the left is what they actually find. Brown areas would be strong magnetic field. White areas is weak magnetic field. By the time it gets in your textbooks, it's nice, neat lines. Okay, it's not actually nice, neat lines that they find down there. It's kind of a jumbled up mess. So as basalt gets hot, it loses its magnetism. So I think the water rushed into the cracks, cooled the basalt, and locked in a stronger magnetic signature. There is no place on the ocean floor where a north-seeking compass will point south. The Earth today has cracks all over it. The San Andreas Fault, the Hayward Fault, the New Madrid Fault. None of my fault, but no question the Earth has cracks. The question is, how did they get there? A couple of weeks ago, I was staying at somebody's house in Denver area, Colorado. And they said, yeah, right off our front yard is the Golden Fault. And you can see where the ground had slipped down. Maybe, I don't know, 70 feet. Just a cliff. That was one of the fault lines of the Earth. I stood right on top of the San Andreas Fault in Lompoc, California. That's the weirdest feeling. You know, you're driving along, and all of a sudden it goes this little mountain range. You know, you go up the mountains and come back down, and you realize you're in the middle of a valley. A little sign, San Andreas Fault. You drive another quarter mile, and you're out of it again. Well, when I was in Alaska, Mom and I stayed on the 12th or 13th or 14th floor, I forget, of this motel that was built 30 feet away from the San Andreas Fault. They don't call it that up there. It's got a different name, but it's the same crack in the Earth, okay? They said in 1964, the Earth dropped down about 30 feet. And so they smoothed it out and planted grass. I mean, looked out the window, and there was the grassy slope. We could see it, I mean, from here to the burn barrel, away from us. You're just right there. Here I'm up on the, I don't know, 12th or 13th floor thinking, boy, if there's another earthquake, that's a long ways to fall down there, you know. So I asked the guys at the hotel. They said, oh, yeah, this hotel is built on big rollers. The whole building can move in case of an earthquake. The ground is going to move. They're going to hope the hotel moves less than the ground, so it kind of absorbs the shock, you know. Well, if there's several kinds of faults, okay, there's a slip fault where it slips, one slips past the other like this. If you take two blocks of hard jello, smack them into each other, and start moving one down and one up while they're tight against each other, eventually you'll hear it go, as the jello kind of jerks past itself, okay? But take 2 blocks of wood, you can see the same effect. You know, you start putting pressure on pulling them apart, pretty soon it'll have to jerk to equalize the pressure. It's that jerking that causes everything to shake. If they were just sliding smoothly, there wouldn't be a problem. You wouldn't have any earthquakes. But they're not sliding smoothly. They will build up stress for years, 100 years, 200 years, whoever knows how long, and then all of a sudden, it jerks. The ground might actually only move a few inches, but the jerking, I mean, if I put a steel rod against your head and just tap it with a hammer and only move it a 1/4 inch, bam, it's still going to hurt, right? It's that jerking of the ground all of a sudden moving to relieve the stress that causes everything to fall down. That's what an earthquake is. There's also the type of earthquake where there's a strike fault and a slip fault. Sometimes it slips down, sometimes it slips sideways. Sometimes it opens up. And you drop right inside. Well, if you're standing there, right. This picture here shows the crust of the earth being subducted. Now, when we went out to Hawaii and watched the volcanoes, I was preaching there in Hawaii, so I went to see a couple of volcanoes. As the lava flows, you know, here's this river of melted rock. The surface cools off. It's in contact with the air. And it gets a skin on there, like when you're cooking gravy, you know, you get the skin on your gravy. That surface, once in a while, will fall down inside the hot rock and get remelted. The surface of the lava can do all sorts of crazy things. You know, it can crack and move around and slide around because it's kind of floating on top of this, you know, liquid rock underneath. The theory is that the surface of the earth, the crust of the earth, is floating on a hot magma core. Probably true. I don't argue with that. I don't know that it's true, but it's probably true. And they're saying the surface of the earth is being pulled under in certain places. So at the mid-Atlantic ridge, it's coming up and moving out, and then it's going being areas of subduction where one is sliding under another. This could very well be true. I'm not arguing with it. But the theory, why this is so important is what I want you to see. This is so important to save the evolution theory, okay? The continents, as it rains, like last night when it rained, some of the dirt washed out of my yard. Which way did it go? Toward the ocean, right? Eventually it's going to end up in the ocean. Every time there's a rainstorm, or a landslide, or a mudslide, or ground creep, or mass wasting, or any of those things, the ground always falls down. Never goes up, right? Eventually, all of the mountains are going to erode and wash and fill in the oceans. That's inevitable. When I was in California, one of my students brought me this chunk of polished rock. It was about yay big and about 1 inch thick, and it was really beautiful rock. I mean, I had quite a rock collection there, and the kids knew I liked rocks, so they brought me this gorgeous chunk of rock, and I said, "What is this?" He said, "You're not going to believe it." I said, "Well, tell me. I've never seen anything like this. Sort of like a granite, only just really bright, beautiful colors. I mean, blue and everything else in this rock." I said, "What is it?" He said, "Well, my dad's company sends people out into the Pacific Ocean, and they've got this big machine that blows water down and blows all the dust away on the ocean floor and gets down to solid rock. Then they saw pieces of the rock out. And they take it back and they cut it up in slabs and make countertops for people. So people can say, my countertop came from the bottom of the Pacific Ocean. And it's just unbelievably expensive, you know, because it'd be expensive to get it. And it was pretty, but it wasn't, you know, wasn't that pretty. Okay, I wouldn't go to the bottom of the Pacific to get any, that's for sure. But he gave me this piece of it. It's probably still, I left all that stuff in my science class when I left out there. But they wanted to have the rock from the bottom of the Pacific. In order to get to it, they had to blow the dust out of the way. Well, how much mud and dirt and silt is down there? When they calculate how much silt is in the ocean compared to how fast it's coming in, all you got to do is run the numbers and you'll find out it's only a few thousand years worth of mud in the ocean. Our little pond gradually gets mud and leaves in it, right? When you went in there to clean it out last time, the first time it had been cleaned out in probably a year and a half since we built it, it was, you know, a quarter-inch of mud in there. Let's just assume it gets a quarter-inch of mud every year. The pond's only 2 feet deep. Eventually, if we did nothing, it would fill in with mud. Just that's the way it happens, okay? Eventually, the oceans are going to fill in with sediment. So how much is there? Well, they find out there's only a few thousand years worth of accumulation. Well, those who teach the earth is billions of years old don't like that idea because, you know, they know the earth is billions of years old, so why is there only a few thousand years worth of mud in the ocean? What's their answer going to be? They've got an answer for that.
Evaporates and then rusts.
No, they're saying the whole ocean floor is being pulled under at the edge and coming up new stuff in the middle. Just like a conveyor belt, it takes all the sediments down in, remelts them, comes back up, and so the ocean floor is constantly cleansing itself. That's why there's no mud down there. Okay, I suppose that's a possibility. But there's another possibility why there's only a few thousand years worth of mud down there. What would that possibility be? It's only a few thousand years old. That's right. That was a flood 4,400 years ago, just like the Bible says, and maybe that's why there's not much mud down there. But all the textbooks teach the continents are moving, and they say they're moving about as fast as your fingernails grow. Fingernails grow a little faster than toenails. I think it grows from where it comes out to the end, which is called the cutting length. I used to know the numbers for biology class. I think it's like 130 days or something like that. 3 months or 4 months it takes to get from here to here. Well, if it takes 4 months to grow a ½ inch, or say it grows an inch a year, to pick a number, okay? If the continents are moving an inch a year, it's going to be pretty hard to notice. To try to figure out if indeed they are moving, when this theory came out about continental drift, one thing they came up with was, they said, let's put a satellite up in what's called parking orbit, and we'll bounce lasers off it from America and from Europe. We'll both bounce lasers off this satellite, and we'll check the angle of our laser beam. If the angle is getting wider, then we're drifting apart. If the angle is getting tighter, we're drifting together. Sounds good. Problem is, as the laser goes through the atmosphere, it distorts it. If you ever look through hot air, like on just above the surface of a hot blacktop, you see kind of the wavy lines, you know? That's called atmospheric distortion. That's what causes a mirage. Well, the laser going through the atmosphere is going to cause it to go off, bounce around, and go off course a little bit. Once it gets out of the atmosphere, hits the satellite, comes back, and goes back through the atmosphere. Just the atmospheric distortion of the laser is going to be a certain amount. Get this on the chalkboard here, can I do? A circle is divided up into angles, degrees. 360 degrees in a circle. Each degree, then, is further divided into minutes. 60 minutes in a degree. Each of those minutes would be divided up into what? Seconds. How many seconds would you think are in a minute? 60. Very good. Okay. Just the atmospheric distortion, just going through the 100 miles of air, causes 0.046 arc seconds of distortion. So the laser is going to be off. So here they are trying to figure out if the continents are moving by bouncing lasers off a satellite. And just the distortion is going to cause them to lose some of the accuracy. 0.046 arc seconds. After the satellite was up there for like 8 years, it finally, you know, you can't keep them up there forever. It fell out of orbit, okay? They noticed they had seen about 3 inches. I'm sorry, they had seen no movement at all in 8 years. But because of that 0.046 arc seconds, it could have moved about 3 inches, and they would not have noticed. Instruments weren't that accurate. So they said, well, it probably did move 3 inches in 8 years then. They didn't observe it, they assumed it. And it could have, I don't know. It wouldn't matter to me if it did. But if the continents did move 3 inches in 8 years, what does that prove? Here's their logic, okay? Okay. How far is it from New York to Portugal? Wow. From New York to the Azores is 2,600 miles. About 3,500 miles. Okay, 3,500 miles across the Atlantic. It's moving 3 inches in 8 years. How many years would that be to spread them apart? Millions and millions of years. And their math is right. It's their logic that's wrong. Okay, maybe the continents are moving. I don't know. Wouldn't matter to me if they are. If they're moving 3 inches every 8 years, we don't know that they are, but if they are, would that mean you would measure from New York to Portugal to find out? I mean, if you took the water out of the Atlantic Ocean, you would notice there's dirt underneath. Is all of the ocean floor recycled from the mid-Atlantic ridge? Well, the plates are moving, but that does not prove they've always been moving. It doesn't prove the rate's always been the same, and students ought to be told there are other options to explain this. For instance, here we are in Pensacola, Florida. Interstate 10 runs from Los Angeles to Jacksonville. I've driven on every inch of Interstate 10. It is a long road. If I go up here to the interstate and see somebody headed east at 70 miles an hour, first place, if he's going 70, he's going to get run over, right? From behind. By us, that's right. Good, Eric. Does that prove he started in Los Angeles 4 days ago? No, he might have just got on at the last exit, right? If we see the continents are moving, does that prove they've been moving for millions of years? No. They might have started moving at the flood. If the fountains of the deep broke open, continents slide away, gradually slow down, and we're still today seeing the slowing down. The Earth is still getting adjusted. It got hit pretty hard 4,400 years ago. Had a rough life. Things are still settling in, still moving once in a while, still have an earthquake once in a while. It's all still settling from the flood. That is, I think, just as reasonable of a theory. Next week, when we come back, we'll take up with more on the continental drift and on the flood. And next week, we'll start our CSE 104. So if you know anybody who wants to come join the class, tell them to come on. We're doing it, getting it on tape. We have about 200 students, I think, now total, don't we, Becky, in all the classes? In CSE 101 and 102. And, yep. So hopefully it's been a blessing, and get more on that next week. Okay? Thank you so much.